you do something else, right?
Okay.
You're quite advanced actually.
Try to remember.
Mm.
Okay. Oh my God. Huh?
F2. Ah.
Okay. Wait, let me.
They find F yes.
Mhm. So F is from X. F domain. Forget how to find domain.
Mm-hmm. Yeah. Oh, find the range. Find the range is.
It's the domain of the thing, is it?
Yeah. Domain of F inverse is the range of F.
Okay, so.
Yeah.
So it's.
Then you do this one, bx minus. Oh, x is not equals to a over b. X is not equals to something. Bx minus a is not equals to something. X over then you must do this one now. X over bx minus a. You simplify, right? Abx over b. No. Ax minus a over b. Plus a over b. Okay. Yes.
Oh.
A square over b.
Why do you need to minus AB and plus AB? Isn't it just 0?
Yeah. That's the thing. Minus something plus something. Yeah. Bx minus a. Oh, okay. Yeah.
I don't get it. How do you get to this?
Wait. You're allowed to speed up.
But how do I know how to split it up?
This one is a over b times bx minus a. Okay, you understand? Okay. Yeah. A over B times B is A, correct? This one. Agree?
Yes.
A over B times minus A is how much?
Negative A square over B.
Yes.
But how do I know to split it up like that?
You must make sure this one, the denominator cancel. So you put bx minus a, so that the bx minus a must cancel.
So what's the point of doing all this? You're trying to find the range, right?
This is important to find the range. Yeah.
Okay, wait.
Then this one, you minus a square over b plus a square over b.
So I work backwards, is it?
Yeah. A square over b, a square over b, a square over b. Then you fill it up here. How much? How much? 1 over bx minus a is not equal to something. A square over b over bx minus a over b plus a square over b over bx minus a. Okay, fill up all this.
Okay, wait, let me try to understand.
Which one you don't understand? This part, right?
This whole part.
Which one?
This whole part.
This part. Yeah. Or maybe I give example here, right? I give example on the next page here. Yeah. For example, 5x plus 3 over x plus 2. Like this, right? If you see this type of fraction, this one is called improper fraction. This is improper fraction. You know why? The order at the top and the order at the bottom are the same.
You say again?
The order here.
Order is different.
Order is the same.
Order is the same.
This is first order.
What do you mean by order?
The power here, power 1.
Oh, okay.
You must you change it into proper fraction. How to change it into proper fraction? You get something plus something x plus 2. Yes, you know how to do this? Try.
1 plus
Okay, we do together here.
Yeah, wait.
Okay,
Wait. Oh no. Wait, I got locked up. Hold on. Wait, my Jamboard jam.
Okay.
Okay. correct?
Yeah, correct. You get, oh, yeah, like that. Yeah, like that. This is the same principle, just that it looks very confusing because we are using A and B.
Okay.
Yes, well, want to try something else?
Yes, try something else.
Uh,
Something a bit more complicated.
yeah.
Try.
5x minus 4x plus 7 over 3x minus 4. 3x minus 5. Okay, so it's a little bit more complicated. So basically, yeah, this is the one that you try to do. You try to cancel out the x plus 2.
Mm. Mm. Like that?
Wrong. Eh? Correct. This one 4 over 3 times 5. 4 over 3 is 20 over 3. 4 minus 20, so plus 41 over 3. Yeah, correct. Yeah. Then
Okay.
simplify.
Oh.
There you cancel this thing. Yeah. Like that. Okay.
Mm.
What if okay. Now I give you a little bit more complicated this one. X squared minus 2x squared minus 3x plus 4 over x plus 2. Try.
Oh, I learned this last year. 2x plus 2, 2x squared, 4x. Okay.
X plus 2. Oh, 4x. Yeah, correct. Yeah. 14. Yeah, correct. Yeah, you understand.
Mm.
Now you
Learning
understand this
accelerated
one?
math.
You want to try to derive it again yourself? This
Okay,
one?
let me try.
Erase now, right?
Yeah.
Is the same, but it's A and B. They try to confuse you.
Okay. AX. correct?
Yeah. How come yeah. A over B. Yeah, correct. Yeah, correct. Yeah, see, you can even do it faster. Try, find this thing.
Oh.
This is the domain of F. Mm.
Bx. Is it A?
Yeah, yeah.
Oh, okay.
Because it times B both sides.
Yeah. E. 0. Correct?
Mm. Yes, 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 yes. Then the last one here.
Also 0?
No,
Huh?
this is 0. If you add A over B, then this one is, you must add A over B also.
Oh.
Okay. And this is fx. Okay.
Fx.
So fx is not equal to A over B. Then this one is range of f, which means domain of f inverse. Okay.
Wait. I don't understand this part.
Which one?
How do you get this? Oh no. Wait, wrong. How do you get this?
This thing is fx.
Which one?
This part is fx.
Uh-huh. Mm.
Fx is equals to this. This is equals to fx also.
Mm-hmm.
Agree?
Mm-hmm.
So this whole thing I replace with fx.
Oh, okay.
You're allowed to do that, right?
Yes. Fx.
Then that's why it's RF is like this. And RF is same as DF inverse.
Oh.
Okay.
Okay.
Then you put here. Then you
Isn't this the same as what I got here?
which one?
Cannot be this and this. Oh wait, it's not showing up. But so the range of the F -1 and the domain is the same.
No, you must flip it. That means range of F is domain of F inverse.
Oh.
Yeah, is you must flip it. You exchange. My domain is your range. Your range is my your domain is my range.
Okay, so wait, range
inverse of each other.
Range of fx domain of wait. Is it?
Yeah, yeah, correct.
Okay. Oh, so since now you want the domain of the f negative one, you have to find the range.
Yes, range of f.
Ah, okay.
Okay, I make it smaller. Part 3, if you don't understand how to do the easy one, it's going to be difficult. I hope you remember for part 3.
Oops. Hopefully I got it out. Okay. Part 2, is it?
Part 3.
We skip part 2.
Oh, part 2. Yeah, skip part 2. Do part 3.
Oh, okay. I remember.
You remember?
I remember. This. You can do this. What's this flip on X?
Yes.
Yeah. I never throw away. Okay. AX equals to A B X squared plus X squared negative 2AX equals to 0. How do I go from here? X AX minus 2A. Oh, X equals to 0. X equals to yes. So answer is this other.
Yeah, correct. Yay.
Yay.
Yes.
Yes. But how do you do part 2?
Oh, part 2. Okay. We duplicate lah. Part 2. Oh, okay. You memorize now. You memorize the. Actually, not memorize. But for now, if range of G is a subset of the F, what does it mean? FG exists. That's it.
Wait, what? Hold on.
A range of F. You understand this notation, right? Subset.
That means it's part of, right?
Yeah, part of. That means nothing comes outside.
Okay.
A range of F subset of domain G, that means GF exists. Last week I explained, but you get confused.
Yes.
You can memorize, but you understand the logic, right?
Can explain the logic again.
Okay. You have F, because FG means F of GX. Agree? Yes. Then this gx here, possible value of gx is rg. Correct?
Wait, say again.
Possible values of rg, possible values of gx is rg.
RG is the range of G.
Yes.
Yes.
And G produce something outside RG? Cannot.
Mm-hmm.
Understand? RG is the possible, the meaning of RG is possible value of
Possible Y values, right?
possible Y values of G.
Mm.
But we don't call it Y now. The Y is G itself.
Mm-hmm.
You understand? No. Don't call it Y, call it G.
Okay.
Yeah.
Mm.
Now, these possible values of G, or we call it the output of G.
Okay.
All right. I give you input that let's say your G. I give you input, then you produce output.
Mm-hmm.
Then your output, I'm F. I take your output, I process, then I produce another output.
Okay. What is the output?
Number.
It's just a number in the graph.
Yeah. Okay.
Okay.
I give example. I give a very simple example. Okay. Fx is equals to 2x plus 1. X is equals to how much? X, I give the domain, right? X is from 0 to 5, like this. Right? Gx is equals to x minus 3. And x is equals to 8 to 20. Yeah? And
okay.
that means you have a machine called F. This machine is paired together with G. Who is in front? If I call it GFX, who is in front?
G is in front.
No, F is in front.
Why? Oh, because you put the F inside G.
You put X into F first.
Can I put F into G?
Yeah.
Okay. Yes.
This is input. This is input of F. This is output of
G.
Are you allowed to put -1 here? Yes or no?
Yes.
No.
Oh no, because it is not.
Yeah, because the domain is from 0 to 5.
Okay.
You're not allowed to put -1.
Okay.
So let's say I put 5 here. Correct? I put 5 here. You process.
11.
You put it into machine F. Then what
11.
is the product?
11.
11. Then 11 I process here. I'm machine. You put into machine G. Then come out how much?
11 minus 3 is 8.
Yeah. Does it mean that GF exists here? Because the whole process, you don't have any problem with this process. No. We check. We check another number here. You sub in 0. You sub in 0.
0.
Come out with
1.
1.
1 minus 3 is -2, which is not part of gx.
No. Even here is already wrong. This is the input of G. The input must be between 8 and 20.
Oh, okay.
Understand?
Mm.
Correct. That means you don't even need to calculate this. This is already wrong because, yeah. So the input of G is DG.
Input of
This
G
is output of F. RF. So RF must be a subset of DG so that the G can process whatever product you can use. You machine F, whatever product you produce, I can process it. Then it exists. If I cannot process some of your product, that means we cannot work together.
Okay, I get it. Yes, I get it.
Yeah?
Yes.
So that's the logic. You have to machine. Yes. Sometimes you machine. Sometimes you have this thing. You want to check whether the G, F, H, X exists.
So must do H first, then F, then G.
Okay. So give me the rule.
Huh?
Give me the rule.
The the range of HX needs to be within, needs to be a subset of F.
DF.
Oh yeah, DF, DF. And the range of F needs to be a subset of the domain of G. Get it. I get it.
Yes.
Yes. Okay. Okay. Then how do I show it? Do I just write this?
You just find the range.
Oh, okay.
In this case, which range you must find?
This one. See whether you must find the range of G.
Yeah, find the range of G.
Okay. Range of G, but I do know the range of G. Okay.
They give you domain for G, then you must find the range of G.
Oh wait, I do not know the range. For all non. So X is not 0. So when the range of G is what? Is 0?
Yeah.
Oh,
that means 1/x is not equals to 0. Yeah.
Okay.
Not equals to 0.
Oh.
Yeah.
And so this range of G needs to but it needs to be domain of F. What is the domain of F?
Domain of F is
domain of F is A over B. Not A over B. How do I know what A over B is?
You don't know. Some positive number, let's say 3 over 5 or some.
But what if B is 0?
Non-zero.
Oh.
If it is 0, then it is confusing again. Don't put.
Yeah. Okay. So it is not 0. No. Non-zero constants. That means non-zero is not that. It is part of, so RG is subset of D, F. And so therefore, FG does exist. Okay, so that's it, right?
Yeah.
Okay.
Yeah. No. No. It's not a subset. Something that is not equals to 0. That means if x equals to A over B, that means it's wrong already. You don't understand.
Wait, non-zero.
If the product is A over B, then it's wrong.
Oh.
You don't understand.
The product is A over B.
Let's say we put numbers lah. Yes, I say A over B, you get confused.
Yeah.
A is 5, B is 3.
Okay.
Okay? Yeah. G. This is machine G. Then you have another machine F. Yeah. Let's say A over B, 3 over 5. You put machine B. X must be must not be equals to A over B, which is 5 over 3. X must not be 0. Okay. What will be here? G is 1 over X, right? You flip it. How much here?
So this is 5 over 3.
Then it's wrong already.
Oh.
It's wrong.
Okay.
You just prove something is wrong, then you say it doesn't exist. Yeah.
Okay.
Okay.
Now how do I write it? Do I say it's not this?
It's not a subset, yeah. Not a subset. Yeah, you cross, yeah.
So FG does not exist.
Yeah.
Okay. So 3 over 5 is just a random number that I take. 3 over 5 is
the
trying to.
example of the wrong one.
Okay.
Yeah.
Yes, that's the domain of. That's the domain of G. So to find the range is 5 over 3, which goes inside there. Okay, I get it.
Yeah.
Yes. Okay.
Okay. You can continue. See, I think